Hi, in today's video I would like to show you that light is a wave. All you'll need is an ordinary glass mirror, like this one on my closet, and a laser pointer. I recommend using a laser pointer from a reputable source so that it is safe for your eyes. The first thing you have to do is prepare the mirror, and for this all you need to do is leave a firm fingerprint on the surface. I've now set up my camera facing the mirror and I've turned down most of the lights. Now if I shine my laser into the mirror, you can see two dots appearing, one on the surface of the mirror and the other behind me is the reflection on the wall. Now if I move the laser to shine into the fingerprint that I've left, you can see a ring pattern emerge on the wall behind me right over my shoulder. And this is the result of constructive and destructive interference, which can only happen because light is a wave. To make my life a little easier, I've stacked up a bunch of books here on my nightstand. And I'll wrap a little bit of tape around the laser pointer so that it's on continuously, so I don't have to hold the button down. And then I'll put it on the stack of books and aim it at the mirror. And then where the laser hits the mirror, I will leave another fingerprint. And this way I can look at the pattern in a minute without having to hold the laser and keep my aim steady. So here we see the pattern again, but this time I have both of my hands free. So now I can study the pattern without having to aim the laser at the same time. And here you can see a long exposure photograph of the pattern. I'd like to briefly explain where this ring pattern comes from. So here I've drawn the laser line coming in from the right, and this blue line represents the glass surface of the mirror, while the black line represents the mirror coating on the back of the mirror, and these black speckles over here represent the fingerprint. Now most of the light of the laser passes through the fingerprint unaffected and then bounces off of the back of the mirror back into the fingerprint and is again unaffected by the fingerprint. And it simply leaves a very bright laser spot on the wall, which you can see in all of the images. But some of the light is scattered by the fingerprint. So it travels forward in a cone like this, and then hits the wall, let's say about there. But another fraction of the light first passes through the fingerprint unaffected, bounces off of the mirror, and then scatters from the fingerprint. But notice now that we have two different paths leading to this point here on the wall, and these two paths have a different length. Now, if that path difference is a whole number of wavelengths, then the waves of the light will constructively interfere, and you will get a bright ring. But if the difference in paths is a whole number of wavelengths plus or minus a half wavelength, in that case you will get an out of phase wave, and the waves will destructively interfere. And in that case you will get a dark ring. And the path length difference changes as you move away from the beam, and that is what causes an alternating series of constructive and destructive interference, which is what gives you a ring pattern. Well, I hope you found that interesting and informative. I really recommend you give this a try yourself. It's very easy to do, and I think the result is really impressive. Thank you once again for watching, and have a great night.